Thank you, Rachel, and thank you, PractiTest, for hosting me today. And today I'm going to talk about connecting manual testers to the Agile era. So hi, everybody. My name is Dror Todress, and I am the co-founder and CEO of TestCraft. We offer a codeless test automation platform for web applications, and I'm going to talk a little bit about it during the presentation. But back to the main topic of the presentation, I'm going to start by discussing digital transformation. And just to explain what do I mean by that, just imagine yourselves, for example, interacting with your bank 10 years ago and interacting with your bank today. I can safely assume that 10 years ago, it was mostly in the branch talking to a teller, whereas today, most of your interactions are done online through digital channels. And that's from McKinsey report showing that trend in different areas of the world. And you can see that the trend is clear. People are moving more and more of their interactions with the bank to a digital activity, to digital channels, rather than visiting a branch. So the trend here is clear, it's global, and again, we're all experiencing that. Now, if that's true for the banking industry, which is relatively slow to adopt new technologies, that's definitely true for other industries, retail, media, other financial services, etc. So in today's world, companies or brands are competing more and more on the digital channels or digital experience they provide to their customers. That has become a major competitive factor for them. And in order to be a leader in that space, they need to be able to act fast, to try different channels, to be able to change them, adapt them, and in short, they need to be agile. Now, this transformation is enabled by a major shift in software development methodologies, and namely the move from waterfall to agile. If you remember in the past, let's say up until 10 or 15 years ago, most development efforts or development cycles were in the waterfall methodology, whereas you develop a bulk of software during a course of a few months. Then you tested it for another few months, you fixed the issues, and then you release, let's say, every year or even longer than that. Today, release cycles are much, much shorter, as we all know. People have shifted to the agile methodology when you release constantly. This allows you to adapt and to support the requirements of the digital transformation. And it entails a major shift in how organizations work, definitely on the tech side, but in general, organizations are more agile and faster in delivering more digital products to their customers. So is Agile the norm today? This is from an HPE survey. The answer is definitely yes. In this survey, 67% are either pure Agile or leaning towards Agile, whereas only 9% say that they're still using waterfall or working with waterfall methodology. What's interesting to see is that there's no generation factor here. You might expect that older generations will stick to waterfall and newer generations, millennials, will be more agile, but there's no evidence to that in that survey. So basically everybody is moving to agile. And when did it all happen? Started back in 2004. Agile started to kick in, and you can see that around 2009, 2010, it started to pick up dramatically. And today, again, most of software is developed in the Agile methodology. What's also interesting in that survey is to see what are the motivations for moving to Agile. And you can see that some of the major motivations are very relevant to our discussion today. So increased level of software quality in organization, that's a major driver for adopting Agile. Again, very, very relevant to testing. Increased customer satisfaction, also a major driver for that, and shortening time to market. So it's all related to supporting the digital transformation, higher quality, faster release cycles, etc. But the problem with all that is that testing was kind of left behind. The Agile revolution, I would say, was mostly around development teams and dev tools for them. Testing teams try to keep up by using their old legacy solutions that were originally designed for supporting waterfall methodologies. They tried to use them for Agile. That didn't work, and testing has started to become more and more of a bottleneck in the Agile process. It got even worse as release cycle got shorter and shorter, regressions got longer. So testing is really a significant bottleneck to the Agile process. And if you add to that this matrix of test coverage, it makes the problem even worse. So test cases are growing, I wouldn't say exponentially, but fast. And platforms and work environments that you need to test on are also growing. You have different environments, different operating systems, different types of browsers, mobile devices. So the matrix is growing, making the problem even more severe. Now, in order for Agile or for testing to properly support Agile, it needs to become a continuous process rather than a step in the process of software release. It needs to go in every step of the Agile process. Feedback from the testing work needs to be constant, much more frequent, and therefore development teams can react to that and continue the Agile process. So the answer of the market, the testing market, to those challenges that I've just described was Selenium. Selenium is an open source project that was introduced back in the back about 15 years ago when Agile started to pick up. And as you can see, this is from Google. That's the interest on Google or search volume on Google starting in 2004. And I'm comparing here Selenium to some of the major or leading legacy testing tools from UFT, from HP, Tricentis, Test Complete, and Ranorex. And you can see that Selenium is by far, it generates the most interest, and it has actually become the standard in that space of testing web applications since then. So this is how the market reacted to the testing bottleneck that came with Agile. So if that's all great, Selenium is great, but it comes with a burden. It comes with a cost, and it basically, if I need to summarize, there are two major limitations that come with Selenium. First of all, it's a coding platform, an open source coding platform. You need engineers to operate it, to write code for you for your tests. That's sometimes hard to find, expensive. Not all companies have the skill set to build such teams, etc. So that's one limitation that is kind of embedded to Selenium. The second one is maintenance. So even if you were able to build a team of engineers to write Selenium scripts, to operate the test automation using Selenium, because of how Selenium is designed, you would need to spend a lot of your time maintaining all the tests rather than creating new tests and move forward. And so maintenance is another major limitation of Selenium. So Selenium is great. It is very successful in companies that have the right skill set and resources to operate it properly. But for many other organizations which don't possess that skill set, it has become very difficult to adopt Selenium and to use it efficiently. And this is where codeless solutions come in. Again, I'm with TestCraft and we offer such a codeless tool. So I'm going to discuss that relating to our solution, but of course there are other codeless solutions out there in the market. Our solution is Selenium based. So we have decided to use Selenium as the core technology because again, we believe that the core technology is great, but with our platform that sits on top of Selenium, we address those two limitations very specifically. First of all, it's a codeless platform. So you don't need to be an engineer to use it. You have a visual interface, which is very convenient, and it is designed for manual testers or functional testers to operate. So we remove that limitations from Selenium. And second is how we approach maintenance. Again, maintenance is an issue with Selenium. We have changed entirely the way that our system is identifying elements. The problem with Selenium, if I get a little bit technical, and I'm going to touch on that a little later in the presentation, the limitation of Selenium is the ability to identify elements correctly in a repetitive manner. And the way Selenium is doing that is quite limited. We have changed it. We're using our own technology, our own set of AI algorithms to help us do that. And we're able to reduce that maintenance overhead that's usually associated with Selenium dramatically, or almost completely remove it. So this is what codeless platforms have to offer today. And let me speak for a second about manual testers and going back to the topic of this presentation. So we want to connect manual testers to the Agile era. I've covered the challenges in the market and the involvement in the market, creating Selenium and then creating codeless tools on top of Selenium to enable manual testers to participate in the Agile methodology. But specifically about manual testers or functional testers, first of all, we think that they have or they bring a lot of value to the organizations that they work for. They have a very good understanding of the applications that they test and the business processes of the organizations. They're also coming from a testing discipline. So they know how to create a test, how to build a test, how to structure a testing methodology. And when you try to port that to an engineering team that is going to build a Selenium test for you, that's not always easy, because an engineer that can write Selenium code in most cases doesn't have the deep business understanding and the application understanding that a manual tester has. So there's a gap there that needs to be bridged somehow. Now, most companies that don't have the skill set for adopting Selenium, they do have teams of functional testers or manual testers. And when you work with a codeless tool, you can leverage that knowledge that they have. You can leverage the fact that you have a team in place that understands the business, and that team could start creating automation for you. So you don't need to have any restructuring of the team, bringing engineers to replace manual testers and losing all that knowledge and information that they have. So that's about manual testers. Again, we've designed our solution for manual testers, for functional testers, to allow them to very easily start creating automation, again, without any changes to the organization. Now I'm going to make a small detour talking about the technology behind Selenium and how a codeless platform could address this maintenance issue. So the main, I would say, purpose of Selenium is the ability to run a test scripts automatically. And the main challenge there is the ability to be able to identify an element correctly on the screen. So if in the test that you've created, you designed, you need to click on a button, you need to be able to identify this button in the next time you run the test and the time after that, and so on. And you need that to be stable and reliable. Selenium, when you write a Selenium script, you're selecting a locator or an attribute that describes or defines this element on the screen. It could be an ID for the element, it could be the name of the element, or many other attributes. And then if you run the test, so the Selenium test is looking for that attribute for a specific element. If it finds it, then fine, it identifies the element and the test continues. The problem with this approach, and this is the core of the limitation of Selenium, is the fact that those attributes change very, very often. From our internal analysis, we just took a sample of 100,000 test steps from our entire user base, a significant sample. And we've seen that in 45% of the time, there are changes in attributes between tests. And this is very, very significant. Attributes tend to change a lot for various reasons, basically because of how web applications are being designed. This is how that's the case. So for example, here, ID, which is considered a very strong locator or attribute, appears in, or is being used in 39% of the cases in this sample, and it changes 15% of the time. So one in every 6 executions, the ID is changing. So the ID is not stable enough for supporting a reliable Selenium test. What we're looking to achieve, or to give you some perspective, let's say you have a Selenium developer which is extremely good. He knows the in and outs of the application, how the application is designed, and is able to find the right attribute in 9 out of 10 times. This is an extreme case of a Selenium developer. Even in that case, you can, because the attributes change 45% of the time, you should expect a 4.5% breakage, which is okay, actually. But a more common Selenium developer, because again, how Selenium is designed, would get it 5% of the time. This will derive a breakage of 22.5%. This is not acceptable. This is not something that you can manage, and this is not something that could scale. So a codeless solution, and namely ours, is looking to do at least as good as a very good Selenium developer, but again, without that developer, without requiring the coding skills. And just to give you a few real-life examples, in this case, you see there's an element here which the ID has changed, and you need to be able to overcome that. Again, Selenium would fail here. A codeless solution should be able to identify that. A change in language. If you're identifying this element by the text, you change the language, then the test fails because the text here is different. This is another change. No, sorry, that's the change in text. This is a change in a placeholder attribute. Again, very simple change, which could also break a Selenium test. So what AI or machine learning is doing in that, in our solution again, but in others as well, is it's not dependent on a single locator for identifying the element like Selenium does, but we actually collect data on all of the attributes for all of the elements on a page. And we're not looking for a perfect match like Selenium, because if something changes, that would fail, but we're looking for the best match on the screen. So if we provide this data to the algorithm, we get back as a result a set of probabilities, and we're selecting that element which has the highest probability to be the right one. And we're actually assigning weights to the different attributes. And even if one of the attributes change, let's say the ID is changing in this case, according to these weights, then we have another 77% of the other attributes that tell us that this is still the right element, even though the ID is changed. So this is the essence of the difference between a codeless approach or an AI approach to test automation compared to the plain Selenium approach. And is it really working? The short answer is definitely yes. The longer answer is here, but we're able to get it right in over 90% of the cases. And we're removing, or if not removing, dramatically reducing the maintenance overhead that's usually associated with Selenium. So to summarize that part, the way to connect a manual tester to the DevOps era or to the Agile era is to first bridge the gap between manual testers and test automation. If it was saved before to a Selenium engineer or to an engineer that could write code, now we've bridged this gap by providing them with a codeless platform, allowing them to leverage their understanding of the business and the application to create test automation without coding. This connects into the Agile and DevOps processes, and it makes overall test automation easier to create and maintain. Now, what would be the best practices, again, from our experience, when you're looking to evaluate a codeless tool or looking to find a way to connect your manual testers to your Agile environment? So first of all, you need to clearly articulate what are your needs and what are your challenges. So maybe you do have a test automation in place. Is that enough? Is that sufficient? Does it give you what you need from a testing perspective? It might be the case that the answer is yes. Then you probably don't need a codeless tool. You have, yeah, you're all set. If that's not entirely true, then you need to ask yourself, does your team have the skill set for creating or maintaining a coding platform? So even if you didn't go into automation yet, then you have the skill set in the organization, you might want to eventually start or build a Selenium framework and use that. But if another question could be, do you have manual testers on the team? And if the answer is yes, then you might want to leverage this team and think about a codeless solution. So this is how I would start evaluating this connection of manual testers to the Agile era. Then when you consider the investment, you need to consider different factors. So not only the cost of the tool, of course, the cost of the tool, but not only that. What are the related HR costs? Would you need more engineers? Would you need to hire more engineers? Would you need to hire more manual testers, or you can use the manual testers that you have in-house? Would you need to train them, educate them? Is their skill set the right skill set for you? And when you think or when you decide that codeless might be a good approach for you, then you should probably research different codeless tools according to the following parameters. First of all, how easy it is for them to get started. What's the time to value? If the solution is very easy to get started, then you can get a number or a significant number of tests started running for you. That's an important decision factor. And then how easy it is to use the platform on an ongoing basis when you start increasing your coverage. And the third question would be around AI and how such a codeless tool would remove or reduce the maintenance overhead. I shared some of our numbers here, but this is something that I encourage you to ask any codeless vendor for the numbers, for the actual numbers or the results of their AI algorithm. When you start, you should probably start with automating the more important user journeys and then push for more coverage. You should start testing earlier in the process as much as you can. And actually, if we go back to the continuous testing notion, you probably should test continuously across the agile development life cycle. Then at the end, if you can, you should strive to connect your testing application to other components or other components in this process. For example, TestCraft has a very nice integration with the PractiTest. So very easily you can integrate a codeless solution which is designed for creating and maintaining a test with a test maintenance platform and see the results and manage the results of your tests on, for example, the PractiTest platform. And if you connect to a CI/CD platform, you can have your codeless platform become an integral part of your DevOps pipeline or Agile pipeline, and that would complete the integration of manual testers into your Agile or DevOps infrastructure. And I think that's the last one. and I'd be happy to take questions.
Hi, everyone. If you have any questions, please write them down at the Q&A at the bottom of the Zoom window. Dror, we'll wait for a second or two. I'm assuming people are
Sure.
still
Yeah.
thinking about it and considering.
Sure. Yeah, so first question here is there free trial for TestCraft? Yes, of course. You can log to our website. You can browse our website at testcraft.io and sign up for that. You can also contact me directly. I don't have my email address here. Maybe I should put it here on the chat. 1 second. So that would be my email address. You can contact me for that. Yeah, another question is, can be used to test mobile apps or just websites? TestCraft is supporting testing of web applications and mobile web applications. So if you have an application which is in responsive design and could work on a mobile browser, then yes, but not native applications. That's another question. How to decide which codeless framework to use. So I touched on that a little bit. I can actually go back here. So I would evaluate what would be, first of all, decide based on the skill set that you have in the organization. Some codeless tools, even though they're codeless, they do require some technical knowledge. Some are geared at manual testers that then don't require any technical knowledge, like ours, for example. So that's something to consider. AI or how AI is going to improve maintenance for you. That's another something for you to evaluate. How easy it is to, after you've created the bulk of tests, how easy it is for you to manage them, maintain them, create more tests, reuse tests or reuse processes across different tests. So many different factors that you can evaluate. Not being very familiar with test automation, what is an acceptable percentage or level of test breakage? I would say that between 5% is acceptable. It could be manageable. It depends what type of breakage, but that I wouldn't go too deep into that now. But 5% is reasonable. Is reasonable. And again, with Selenium, we're talking sometimes about 20 or 30 or 40%, which is not scalable. And actually, talking to Selenium teams, in many cases, they do get value out of that, but they're reaching a glass ceiling that doesn't allow them to develop more or to test more or to cover more because of this constant chase after maintaining their existing tests. So that's kind of what limiting Selenium teams. In what test environment is applicable this approach? If you have several environments as dev, reg, pre-prod, and prod as steps, how this approach is applicable. So most codeless solutions will allow you to run your tests, to create them once, and then run them on multiple environments. For example, in our platform, you can say, I have a test, I've created the test on my testing environment now, and I want to run it from Chrome, but now I'm going to run it on the production environment on Firefox. That could very easily be done. So that's actually an advantage of, test automation in general, and of course for codeless test automation as well. think I got it all.
Dror,
And any other questions? Yeah.
yeah, actually, I had a question as well.
Okay.
I wanted to ask you, do you have any other tips or ideas about connecting the manual testers, but not in regards to tools, more in regards to the state of mind, the team approach, things like that?
Yeah. So I think that would be relatively easy because they're striving for that. So in some cases, they're feeling like, left alone, and going back to the value that they bring to the organization. Again, I believe there's real value there. Uh, and once, I think it's tool related. If you're dependent on a coding platform, that's going to be very difficult to involve a manual tester doing manual testing in an agile team. It happens sometimes, but it's very difficult. It's not fast enough. It's not scalable enough. Uh, I think any tool is key. Is key for that, for involving them in the process. And again, any codeless tool could do that.
Yeah, but in the Agile era, well, some people will say that take the developers and have them test, have them code and test.
Yes. Yeah, I touched on that a little bit. That's easier said than done. It's a different, I would say, profession. Being a coder is very different from being a tester. A tester is a profession by itself. You need to think as a tester to be able to challenge, to be very, how I should put it, to challenge the application, to think creatively how to break the application, how to find issues. It should be a challenge for you. It's a different type of person, a different type of profession, very different from a coder. Now, coders do test their own code, but they're usually not the right profile for testing the functionality of their application. So they need to be able to check their code and test their code, but not the functionality of the application. From an end-to-end perspective, this is something for a tester. So if you give that to an engineer, you're going to lose a lot of that value that a manual tester could bring.
Okay, terrific. We have another question from Todor. How test incidents are handled?
Yes. So I will let you answer one part of that, how it's done on the PractiTest side. On our platform, we report, of course, on the results. We do point the user to the specific location and specific element where the breakage happened or where the test failed. And we give them a very easy way, again, a visual way for fixing a broken test. If it's a broken test, it could be that we've identified a bug and that's being reported into another system like PractiTest or like an incident management platform for the engineers to handle. So again, a broken test is very easily fixed by the tester visually on the screen. A real bug is being pushed into the process of dealing with bugs in the organization.
Okay.
And you want to mention how it's done on the PractiTest side?
Yeah, from our side, assuming the person who asked the question is talking about, as you said, bugs or issues that are found in the in the process. So first of all, as you said, also at TestCraft, but also in PractiTest, there is a very visual dashboard or report that lets you have a full vision and a full coverage of the entire process, from requirements through test sets, and then of course issues. You report the issues. If you're using the issues module in PractiTest, you can assign it to a developer. If you are using a different tool, I don't know, Jira or whatever it is, then we have a two-ways integration. So it is as if you're working with the same tool, but you're using only as if you're working with both tools, but you're using PractiTest only and having everything centralized there.
Yeah. And we have another question from Tudor. Is this approach applicable for test of ERP? If the ERP is a web-based platform, then definitely yes.
Okay, terrific. Anyone has another question? Okay, so I will say thank you, Dror, for.
Okay, thank you. Thank you for having me.
Yeah, we loved having you. I think it was an insightful talk, even for me that, you know, I'm not from the industry itself. So thank you for that. Thank you everyone else for joining. If you liked what you heard here from Dror, you would love the online TestConf. As I said, it's on the 3rd and the 4th of December, or if you're from Japan, it's on the 7th of December. We're gonna have 2 full days filled with great talks by great speakers. You should check it out on our website. It's onlinetestconf.com. Thank you, everyone.
Thanks. Bye.